All right, today we're going to work on complex and imaginary numbers. So complex numbers comprise all numbers you can think of. So all reals and all imaginary are in the complex world of numbers. So a complex number can be written in the form a plus b times I, and you're going to see I a little bit today. A is the real part, and if it exists in the number, b times I is the imaginary part. So even just a plain number, if you want to talk about a real number, let's say I had the number 5. I could write 5 plus 0i. We would never write a number like that because we're just doing that for this example, but any real number can be written in this format. It's just I would put plus 0i. So the imaginary part is what we're going to get into that you guys might not be familiar with. So imaginary numbers were literally invented to help solve math problems, and they do have applications, a lot of electrical engineering and things of that nature. So imaginary numbers, here's your definition. I is defined as the square root of -1. So imaginary numbers were introduced so we can take square roots of negative numbers, which we can't do in the real world, and which is why your calculator won't give you real answers for this, but it does have imaginary answers, which allows us to help solve problems. So that's the definition of I that was created. Now, also because of this, I squared is equal to -1. Let me just kind of try to define that real quick with a number that might make sense to you. If I said 6 is the square root of 36, you guys hopefully would agree with me that 6 squared is equal to 36. And you can see here, I is equal to the square root of -1, and then when I square it, it gives me what's under the square root. So these two pieces are very important when we're talking about imaginary numbers that are going to involve I. Okay, now when you break down radicals under roots here, we're going to break down some square roots. The process is just like it is normally, where you might use a factor tree or you might find the biggest perfect square. The difference is what we do with the negative here, and I'm just going to write this for this problem. I think of this as 121 times -1. So whenever I have a negative, I can take care of that. The square root, this is a perfect square here, square root of 121 is 11, and then I just put the I right next to it to take care of that square root of that negative. So anytime you have a negative under a square root, you can simplify it using the I. Now notice I didn't put a plus and minus, and I won't on any of these problems because the radical already exists in the problem. I didn't introduce the radical. So we'll do plus and minus, but only when we introduce the radical for something where we're solving an equation. Okay, so here square root of 36 is 6. And I just put an I next to it because of the negative. The 3 already exists here, so just like a normal, if something's in front of the square root, we're going to multiply those together. And you can multiply real and imaginary numbers together. So 3 times 6, 18i would be your answer to that question. Now, 29 does not break down under any kind of a factor tree. It's a prime number. This is not considered simplified, though. What you can do here is just go ahead and write this I to take care of that negative, and then radical 29. That's considered simplified. If I got the 12 here, and just like in class, if you like the factor tree, use the factor tree. I'm going to tell you the biggest perfect square that goes into 12. This could be rewritten -4 times 3. Square root of 4 is 2. Square root of that negative is I, and then the 3 stays under the square root. 108. Biggest perfect square that goes into 108 is a 36, I think, but I'm going to check real quick on my calculator. Yep, this is going to be, I'm going to do -36 times 3. Square root of -36 is 6i to take care of the negative. 3 stays under the square root. Use a factor tree if you like that better. 54, biggest perfect square that goes into 54 is going to be 9. So I'm going to rewrite that as -9 times 6. Taking a 3i out in front for the negative. 2's already there, multiply these guys together. 2 times 3i is 6i, and then this 6 can't break down any further, so it's going to stay under the square root. For example 2, this is just a quick demonstration to write these in the form what we call a plus bi. So any real parts are going to go first, any imaginary parts are going to go second. So this would literally just say -7, and then square root of 64 is 8. Square root of -64, we just put an I with it. That's all there is to that problem. This one right here, in terms of the -18, that's not a perfect square like that previous question. So I'm just going to break it down. Biggest perfect square that divides into 18 is 9. This is going to come out as 3i. So 5 minus 3i radical 2. The 5 is the real part. The -3i radical 2 is the imaginary part. Over in this question, -7 is the real part, and then the 8i is the imaginary part. But you can see it's in this format. Adding and subtracting, this is literally just combining like terms. You're going to add the real parts together. So 3 and 4 is 7, 6i minus 8i would be minus 2i, and that's my answer. For this question, if you're doing subtraction, I would just encourage you to do one quick step, because you have to subtract both parts of the imaginary number. So this is going to be -2 and then minus 5i, then combine your like terms. So 9 minus 2 is 7, and then 7i minus 5i would leave me with a plus 2i. Those are my two answers there. Okay, just flipped over to the back here. These are add and subtract questions also, but you guys can see that what I'm working with in these problems is not quite simplified. So I'm going to go ahead and simplify any parts of this that I can. I'm just going to keep that at 2. The square root of -16, we'll change that into a 4i. Notice this doesn't change. This is a plus sign, so I'll just go ahead and drop the parentheses, nothing to distribute there. This is going to stay exactly as it is. The square root of -25 is 5i, and then once I'm there, I'm just going to combine like terms. 2 and 8 would give you 10 for the real part. 4 minus 5i is just going to be -1i, or just -i, and then that's my answer. Now for this one, nothing in front of the parentheses, so this is just going to be 6 minus. Now square root of -1, that's the definition of I, so this is just going to be 6 minus I. Now here, real quickly, this is going to be -3 minus the square root of -64. So 6 minus I minus 3 minus. Now this does not cancel the negative. The square root of 64 is 8. The negative is going to be I, so this is going to be minus 8i. And then from here we're going to combine like terms. 6 minus 3 is 3. And then -i minus 8 more would be minus 9i. So 3 is the real part, -9i is the imaginary part. Okay, just a little tip here above example 4. You can go through and read it. I'm going to kind of explain it as I go through and do these multiplication problems. You can always multiply complex numbers. You can only add if you have like terms, add and subtract, but you can always multiply. So here's how this works. 3 times 8 is 24. Now here's the key. I times I becomes I squared. And I'm just going to write this again. I know I wrote this on the front. But if you get I squared, that is defined as being equal to -1. So really what I have here is 24 times -1. And when I multiply these sometimes, this actually gets completely converted into a real number. The answer here is just going to be -24, no longer imaginary. Now, this is -5i squared, so the -5 gets squared and the I gets squared, both of them. So you're going to square both. This would become +25. This would become I squared. And then this is pretty similar to the problem we just did, because I squared, again, is going to turn into -1. So this is going to become a real number here. -25 would be my answer to that. These last two, this is just going to work like a normal FOIL. I'll do one with a FOIL, which I think of more of as a double distributive property, and then I'll work through this one with the box, and you guys can use whichever method you like better. So same way a FOIL works, I'm going to do 3 times both of these terms. So 3 times 2 is 6. 3 times 4i, 3 times 4 is 12, and then you just go ahead and keep the I next to it. Negative 7i times 2, negative 14i. Negative 7i times 4i is negative, 4 times 7 is 28, I times I gives you the I squared. Now, in the middle here, I can combine these. So this is 12 minus 14, so that would be minus 2i. You're not going to combine it here, though, because this is an I squared. Now, I squared, remember, converts into negative 1. So here I have 6 minus 2i. This term on the end, it's minus 28i squared, so it's negative 28 times negative 1, so it's actually plus 28. Now, we're still going to have an imaginary part here, but I can put the 6 and the 28 together. Both of these are positive, so this is going to turn out to be 34 minus 2i. And just when you have these questions, the real part should be written first, and the imaginary part should be written second in that a plus b times I format like we had on the front, so just keep that in mind. Okay, now if you like the FOIL, go ahead and do that. If you like the box better, I'll do this example with that method. So I have negative 1 times 6i, and then I have 5 times 9i, and I can write those terms, you know, I could switch, I could put the 5 and the 9i over here and the negative 1 and 6i across the top. We should get the same answer, but I'm going to kind of do this as a Punnett square, the area of each box, if you will. So negative 1 times 5, this box would be negative 5. 5 times 6i, 5 times 6 is 30, and we'll just have an I next to that. Negative 1 times 9i is going to be negative 9i, and then down in the corner, 6 times 9 is 54. I times I is I squared. So remember, I squared always turns into negative 1, so this corner box down here is really negative 54. Alright, so I'll slide this up so I have a little bit more room. I have negative 5. I'm going to put this negative 9 and the 30 combined like terms. That'd be 21i. And then I have this minus 54. Now, that can be combined with the negative 5. So both of them are negative 59 plus 21i. And then we can't simplify any further there. Okay. Now, the entire purpose of us introducing this into your repertoire for solving mathematical problems is these equations down here at the bottom. So when we worked on this a couple days ago, we would have said these have no real solution, and that's true, but they do have imaginary solutions. So we're going to solve these just like we were solving the equations the other day. I'm going to get x by itself, so here I'm going to subtract 48. I get 2x squared, negative 48. I'm going to divide both sides by 2. X squared is going to be equal to negative 24. And then here, when I take my square root, I'm introducing the square root into the problem. So that's where you want to go with that plus and minus symbol. When you introduce that into the problem, you are giving that possibility of a second answer. And I'm going to break this down since this is not a perfect square. If you like the factor tree, use that. I'm just going to tell you the biggest perfect square that'll divide into 24 is 4. Now, only thing I'm going to do here differently than a normal radical is when I take square root of 4, I must take it as the square root of negative 4. So this is going to come out as a 2i and then a radical 6. So these are my two answers here. This symbol means I have positive 2i radical 6 and negative 2i radical 6. So there's two answers. Okay, one more, just a little different looking. Now, remember, if you've got parentheses here and they're squared, we don't want to FOIL if we don't have to. So here's what I'm going to do. I'm going to isolate those parentheses. Get them by themselves. Whoops, pretend that says it's a minus. But I'm going to start out, get the parentheses alone, because that's where the x is at. So that'd be negative 60. Do not ever distribute when you've got an exponent in your order of operations. We would have to FOIL that first, but I'm just going to try and cancel those parentheses out. So I'm going to go ahead and divide by 3 here. This would be x minus 2 squared. This would turn into negative 20. And then, this is why we don't want to FOIL, because I can just take the square root there. The square root and that squared cancel each other out, so you can just drop the parentheses. Now, don't forget your plus and minus. And I'm just going to break this radical down as I go real quick. Factor tree if you want. The biggest perfect square that divides into 20 is actually 4. So I'm going to rewrite that real quick as negative 4 times 5. Now when I simplify this, keep that plus and minus out in front of that, this is 2i radical 5. And the only difference is the last question I had x by itself. Here I just need to take one more step and add that 2. Now you cannot actually add that. This is the real part and this 2i radical 5 is the imaginary part. So sometimes these solutions can look a little bit more complicated than just a plain number. So my two answers here, 2 plus 2i radical 5 and 2 minus 2i radical 5.